Okay, hey guys, I know it's pretty late and we've had a lot of talks and you're quite tired, so we'll get through this quite quickly. So I'm just going to give you a bit of an overview geared to those who are doing a science project. So I did my BMedSc last year. I did it actually with Megan, which is not the reason why I'm here. But and I looked at the trophoblast cell, which is from your embryology days, you might remember, is part of the placenta, and a protein marker called TROP2. And wait, is this recorded?
Yeah.
Okay. It was really hard. So that's just a thing that if you're doing a science BMedSci, like, don't panic. It's a universal experience to feel like an idiot for literally the first 6 months of your BMedSci. And there will be times where you read an article and you're just like, I don't even understand anything other than the abstract. Like, I literally cannot read this article. And that is fine. And it's hard because you've obviously all come from med, where you're very clever cookies, and you sort of, like, you don't know what's relevant. You'll read these articles and you'll think, oh, is this MAPK ERK1 pathway relevant, or is it like sort of like a maybe one of the theories? And it's quite hard to figure out if it's important or not, and that's where your supervisor comes in. That's when you should have that rapport that you can send them an email and say, what this relevant? Or you can just go and ask them like, hey, I'm really confused. Should I bother getting invested and reading about this, or should I just like make a note of it and move on? But with regards to the actual lit review, so when you're writing a lit review, you have to think very straightforward, as we've all been talking about tonight. Like, what's the whole point of this? Why am I doing this? And you're pretty much going to be doing 3 things in your lit review. You're going to be summarizing the literature and making a critical appraisal. So have the guts, I guess, to take a stand and say, this is what the evidence suggests, and the evidence is good, or the evidence is bad. Because what a lot of us do is we'll just say, the evidence for this topic is X, Y, and Z. And you will never say, but I reckon Z's not correct because of, that's what makes you a more mature writer, is if you can take a critical appraisal of the research, as opposed to just telling them what the research is. So you want to be summarizing the research. You want to impress the relevance of your topic. You want to hype them up and say, holy shit, like, improper placentation is the end of the world. We need to fix this. And then you need to say, and that's why my project, which is, going to do this sort of mechanism and explore that type of pathway, is really going to help this horrific problem of placentation that everyone cries about at night. And I'm genuinely, like, not trying to like overemphasize it, but you're going to be referencing in 1 or 2 sentences A, B, and C at the end of every section, and pretty much always A and C at the end of each subsection. And you're going to feel like you're reinforcing the same concept too many times, but you need to do that. You need to be constantly reinforcing, because your lit review is pretty complex and fancy, and your reviewer is not paying attention. And that's just sort of like, you just got to keep doing it over and over. And yeah, just check the marking criteria. Megan's very, very sensible. So she writes a marking criteria that she wants examiners to follow to the dot. And if you follow the criteria, you're pretty safe. So when you're doing a science, so whoever's doing a sciencey BMedSci, you might feel a little bit overwhelmed by the number of articles that will have your keywords in them. And that's because a lot of the scientific concepts will overlap. So signaling pathways can be ubiquitous. They can be in like every single part of science. It can be in cancer research and like, gynae research and cardio research. And you might be like, oh God, do I have to read all of these papers? How? I don't even have time to read like 5 with understanding them. But don't panic. Unless you're writing a systematic review, you're not meant to be reading all of them. There are papers that you don't have to read as long as you cover the basic concepts. And your supervisor knows that. They know that you're just going to be covering the relevant bits, and probably not even to the detail that you all deep down think that you need to do. They actually really want quite a superficial sort of amount of detail. Don't spend days reading old content. In science stuff, things change really quickly, especially, articles from 1990s. Nah, like, let a review article tell you what the old theory was, and spend your time on what the current theory is. And that's really important for word count. No one's going to care if you write a whole paragraph about the previous, existing theory on placentation was blah, blah, blah. But then recently they've discovered you know, sorry, I ran out of words. I can't tell you what they just discovered. So it sounds really like common sense, but and then there's the rabbit hole. A lot of scientific articles take you down this rabbit hole, and you're sort of like, where is this going? It's linking something else. I need to read about that other thing so I can understand article A. And you might just be spending a lot of time on something that's not important. So just check with your supervisor, if you can. Some supervisors like aren't around. So this is formatted weirdly, but when you're starting off with your overview, the best people to ask is your supervisor or to read a review article, because that will tell you really where your research ends, so you don't feel like you're wading through this like bottomless pit of things to learn. Your supervisor will say, here's the main concepts on this topic, or the review article will say, here are the main points that you need to cover. So just as an example, I looked at placentation, and my background literally included stuff on the menstrual cycle, which seems so basic, but Megan said it was important to provide background. And then I went into each of the things. I went into what a trophoblast cell was, and I went into what the protein was, and I structured it in that way. When you take notes, everyone's been saying this, but you make a subheading, and I think the easiest way of doing it is to have a specific question, and then have a table that says, you know, who was the author, what was the year, and then a different box you can have, was there anything important with the study design? If you're doing a clinical project, you can often, like at the start, you'll read a clinical trial and you'll be like, oh, that's dodgy, they didn't include the right people. But sometimes when you're doing a science topic, you'll read an article and you'll be like, look, there's a methodology where I don't understand any of the words. And so it's hard to know if the study is good or if it's bad. So don't worry, just write down what it is, and you can go back to it later on, because you might not know at the time if that's actually the right way of sciencing. Does that make sense to you guys who are doing science topics? Like, no one else understands unless you do a science BMedSc and you cry a lot. So, and then with PDFs, I really recommend saving them, because again, you may not know what's, like which part of your article is actually going to be important. You can type on them, you can highlight them. And EndNote has a smart groups feature, and that's really good, because if you've got over 100 citations, it's nice to be able to break it up into, oh, that was a reference for this paragraph. So that's quite a handy thing. Just a little bit about sciencey stuff. So no one really teaches you what basic science concepts was. And I remember in my first few weeks in my BMedSc, I actually looked up a molecular biology textbook, because I did not know what hedgehog family was, or what all these variety of integrins and ligands and receptors. I didn't know where it all fit into the big picture of science. And so I made myself a table, and I said, these are the common types of concepts I'm going to be talking about. Like, these are adhesion molecules, these are signaling pathways involving these types of things, these are gene cycle regulators. And it kind of helped, because then I could read an article and say, oh, it's talking about this pathway, and I look at my cheat sheet, and my cheat sheet would say this pathway is common to these fields. Do you remember the Bradford Hill criteria that we did in 3rd year or 4th year of ABCP? That's pretty much like really common things about causation. And in science, one of those is like, if X causes Y, then more X will cause more Y, and less X will cause less Y. And that's the way that a lot of scientific study designs are based off, is that sort of principle of, to prove a point, here are the things that you need to do to prove it. So if you're reading a scientific article and it's only doing one, like it's only saying that this gene promotes this pathway, but it's not showing you that stopping that gene reduces that pathway, then you know that it's insufficient. It's actually only telling you half of the story. And it was those types of concepts that I didn't know until I did my BMedSci, because I was just like, oh, look, evidence. And then Megan would be like, but is it the best evidence? And you'd be like, oh, I don't know. And the same thing with looking at controls. You need to really figure out if your controls are appropriate. And then another thing for those who are doing cell work or animal work, a lot of interactions or actions are cell-specific or tissue-specific. So if you're reading somewhere that in prostate cancer, these things happen, but in ovarian cancer, it happens differently, you can sometimes just chalk that up to these actions are tissue-specific, and that's why it's different, as opposed to being like, well, one of them is wrong, who's wrong? Like, it can't do both things. We all know the difference between in vivo and in vitro. Yeah, So that's really important for a lot of you guys in some science research. And make sure you highlight that so that whenever you read the research, you're really emphasizing this was done in vivo. That makes it, in some ways, a little bit more legit than the research that's done in vitro. And also that concept of downstream versus upstream. I'm sure that some of you guys are way better scientists from the start than I was, but I was like shocking. So even just like knowing that downstream factors will have, like if an article talks about a pathway system, you have to break them into the upstream and the downstream factors and then figure out where your topic fits in. Is it upstream? Is it downstream? Therefore, what regulates it? What does it regulate? And something that I did is that if I was really struggling, I would just read the discussion and not get too bogged down by the methodology and then just see if that answered the question. So with writing up, subsections is the best way to write things up that most people say. It's very important to write in active as opposed to passive. So instead of saying like, you know, it was evaluated, being like we evaluate, oh fuck, it doesn't work. Do you know what I mean? Like there's a difference between active and passive, and I'm blanking out because I'm really tired. But instead of saying like, you know, we did a study on this as opposed to these things were studied. You want to be talking in a very active way because that's apparently meant to be a marker of like good science. Do you have a question? Oh, that's all right. Yeah, definitely. And in fact, well, in the literature review, you might not often be saying we because you probably don't have a lot of research to contribute that you've been involved in. But you can say things like my lab hypothesizes or we believe that this is, you know, a prevalent concept. In your discussion and in your thesis, you will be doing that all the time because you're going to be a lot more involved in the evidence process. But in the literature review, you are sort of just critically evaluating what other people have done for most of it. Oh yeah, definitely, yeah. And it's really like you can be a bit more informal than in a super like some like the med assignments and stuff. Like you have to be really formal in those, and you could never do that whole leading someone down the path. But in a literature review, you can say, I'm going to be talking about like, you know, this review will cover X, Y, Z, and then actually go on to cover it in exactly that way. That's completely fine. And then, yeah, filling in paragraphs whenever you can. I was the type of person who wanted to wait till like, you know, everything was perfect and the stars were aligned, and then I would start writing. And it was a terrible idea. Like, start whenever you can. Just write a paragraph. It's going to be super shit, but you can edit it as long as it's done. You'll feel really good about yourself once you start getting paragraphs done. I didn't know that you could disable endnotes. I just used to write like in the author and year and then go back and add it. But Jackie's way of removing instant formatting fixes that, so ignore that. And diagrams. So like the importance of diagrams is just monumental. Genuinely try and have 4 to 5 diagrams in your literature review. And even things that you think can't be a diagram. Like I used a diagram to summarize the key things that regulate my protein, which otherwise would have been a really, really boring paragraph. And I just put it in a diagram. And I thought it was a bit of a bullshit diagram, but they loved it. They were like, great use of diagrams. So if you can do anything to avoid writing paragraphs, put it in a diagram. And it's a really nice way to look like you're summarizing things without actually summarizing anything. So yeah, diagrams are the way to go. When you edit, make sure you know when your supervisor's away. There's nothing like finishing your lit review and then they're just like, see ya, I'm gone to the conference. Getting lots of people to read it. So I didn't get many people to read it because Megan was like a very thorough, like sort of supervisor, but lots of my friends have said that getting everyone to read it made such a difference because your mum has a different way of looking at it than your supervisor does. And your mum will get the things that your non-expert examiner are going to be looking out for. So whether or not it's approachable to like the general public. Keep asking yourself, are you making all the criteria? And be like confident to make a critical appraisal of literature. So I used to be really afraid because I didn't think I understood the evidence that I couldn't make a judgment call, but just like do it, just make a judgment call. And Like, your supervisor will tell you if you're wrong, but it's good to make judgment calls because it shows that you're being all like critical and evaluating and everything. The limit in a science project, you're probably going to feel like your limitation section makes you feel like the whole project's pointless, because scientific BMedScis, by their nature and by the time frame that we're given to do them, can only really chip away at one tiny part of a very complex science process. So don't be sad, that's science. If science was more efficient, people wouldn't like take so long to get things done, if that makes sense. So be comfortable that your project is probably only going to have it fit into a really tiny notch, and use that limitation section to highlight that, because it also makes you look as if you're showing a lot of complex thinking. Back up your end work. All the aesthetic stuff takes a lot longer. They really do like it if you have like a really nicely like laid out lit review and if it looks quite pretty. And use things like page breaks. If you go onto your layout of Word, you can set in page breaks so that there will, like this chapter will always be on a different page, and that way you don't have to like worry about pressing enter to get it onto a next page, and then you add a figure and then it's like halfway down the page and you're deleting. Is that just me? Okay. Anyways, and final advice. So you may have a shit ton of time. You may have lots of time at the end before your lit review, or you might not have any at all. It just depends on your project. Some people have really tricky lit reviews. Don't worry about it. If you're doing a lab project, this is just my advice. Get in the lab super early. Have a really clear plan of the induction courses. A lot of the times induction courses run like twice a year. So if you miss the first one, you're not good. Know what needs to be ordered. So a lot of these antibodies can take up to 4 months to be ordered. And they're very expensive. I would write down where all the equipment is. You will forget. There are so many freezers and things are always in different boxes. And when it's 2 a.m. on a Saturday, which definitely didn't happen to me last year, and you're trying to find an antibody and there's no one there to help you, you'd be very like lucky to have a list. That definitely happened to me. So, and then write down the steps of machine settings, because people will show you how to use very tricky lab equipment and they'll whiz through the machine settings of how to set up things like wells. So just physically write down like clicked file, clicked open, clicked, insert chemical. Because when you're doing it on your own, you might make a mistake, and then that's not great. It's expensive. It's just expensive equipment. And make an experiment timeline. So things are going to go wrong. So give yourself a few weeks for that immuno did not work, didn't work, and then I need to redo this immuno. And if an immuno takes at least 2 days, so if you think about it, if you're gonna have to redo it, you're gonna need to put in 2 days for the immuno, 1 day for drying, and then another day for imaging. So that's almost a full week. So give yourself that time and think about like how long each experiment takes and therefore how much time you need. And yeah, save your articles for methodology. Methodology is the easiest section of your thesis. You literally just like rewrite what other people have written, and there's not a lot of ways that you can rewrite it, so like you're not plagiarizing. But it's pretty much the exact same as what someone else has written, and then you can just write that up in July, and then come October you've already got your methodology ready to go. And yeah, good luck. It's like the science ones are harder than the clinical ones, in my opinion. But you end up knowing so much weird stuff that you didn't know at all at the start. With the marks, a lot of people get a bit worked up with the lit review, and then by the time the thesis comes around, no one cares. But with the lit review, remember, it's a communications exercise, and markers will give really random marks. There's so many different examiners in the BMedSci cohort that someone's going to give an 80, someone's going to give a 90, and you can't argue it. There's no point getting upset. You can't really be like, but I definitely satisfied criteria A, B, and C, because they'll just be like, in my opinion, I think it was good. Here's a 70. So just, yeah, don't worry about it. The quality of your research is much more important than the marks, and that's going to be important for the real end game, which we all know is publishing. So when you come to next year and you want to publish your research, no one cares at all if you got a 96. They're going to care if your research was good. And yeah, good luck. It's going to be totally fine. Yeah. Cool.